Hello again. We have an interesting device today. So this is a Magni 3 from a company named Schiit. Okay, so this device is a Magni 3 headphone amplifier made in USA. So it's looking like one of the outputs, the headphone outputs. It's gone. But for now, I just want to open it up, see what's happening there. And like usually, before anything else, let's check for short. This is the input, obviously no short. What we got here? Obviously input, output, high, low. Probably this is for the headphones output power. And on, off, of course. Well, it's a pretty sturdy case. I like the design. It shows respect somehow. The microscope it's on. Let's take a look and let's see what we got here. First of all, a CBG. What is this? Probably these are transistors. Yes, Q1H2. We have a circuit here. This is an MZ833. That should be an operation or something. And the other channel, oh, this is different. MZ713. Okay, what about the transistors? So we got an A1552 in pair with a C4027. We'll take a look at this in a second. And then we have these transistors here, T8B. Going to the next pair. This is a complementary CD-T8B plus T3K. Okay, got you. What about these resistors? These are 4R75, very clear, 4.7 ohms. Okay, what else? As I can see, we have this evidently high temperature burn. I should have some more sink around this power transistors. That's enough for now. Here I have the power supply, AC adapter that delivers 14 volts AC, 1.5 amps. Let's check this first. Yeah, it looks okay. 0. Let's power on. We have the LED lit regulators. So clearly we have a differential linear power supply regulators. 317. Also, we have a relay here. And now the relay is on. So we have a delay circuit in this area with a relay and 2 diodes, a transistor over there. You heard that? Like 10 seconds or something. Okay, let me take this out from the case. I have much more freedom. Easy set. Oh, of course. It's out. Let me have the diodes checked. Perfect. So it's on. I could hear the click. Now let's check these voltages before and after the regulators. So here we have 23, 22. It's a lot of voltage. A lot. And then here we have 16 and 16. Okay, looking good. Minus 16, that's fine. 16, minus 16. Slightly warm, probably a bias current of some sort. I can hear the relay pushing on and on. 46 degrees, regulators 43 and 41. And this one, LM337. Okay, it's 337 LM, of course. This one is getting hot-ish. Now, both are pretty equal now. 42 and... Alright, so let's go to the transistors. This one is kind of 54 degrees. What about this guy? Nothing. And... Okay, people, so now here I have the headphones connected to the amplifier and of course a signal in from my phone. So far, I found one of the channels. It's really distorted. In between the things, and what I found, we are on voltmeter here, ground. On this output of this transistor there is a minus 5 volts, and the other one, the good channel, 0.6. Here I have minus 5, but here I have plus 0.6. The input 16, 0.18. Let me check the other guy. 16, 0.002 something. It's looking good. Minus 15 here, minus 15 there, minus 16, minus 16. The difference is here. The middle pin, it's presenting a 5 volts. Well, I'm gonna disconnect this pin, just lift it in the air, and this too, and let's see what's happening. Power off, obviously. Got it, it's in the air. Let's measure voltages now. I'm not exactly happy with the result, so I'd rather take this out. Perfect. Okay. Right. Let's have this also out. It's easier without the hot air. Yes. Okay. Both guys are out. Let's measure with the multimeter first. Diode. Nothing. 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 Zero. Okay, so this one, I have a good junction here, and that's a good one. Okay, so this transistor, it's okay. This one is burned. Very, very, very clear. What can we do? This is still alive. So what is this? C4027. Let's take a look. It's an NPN transistor, 160 volts, 1.5 amps. So this is still alive. But this one, which is A1552, it's a bipolar transistor. This is a PNP transistor for sure. Let's take a look, a better look. Point is that this one, the PNP, was absolutely overheating. I think I'm gonna have some better heatsinks, so I have to find a PNP transistor to replace this guy. For now, let's put this back. C4 right here. We'll do some better cooling, something, probably some small heatsinks. Good. Now let's see what's the story with 507. I will just simply put this in place like this for testing. So I have 1, 2, 3 base like that. Come on. Perfect. And collector just for a test. Perfect. Everything is done. This is properly in place and power on. Oh, headphones, of course. Perfect. Perfect sound, no more distortion. Yeah, so we did it. That was the problem. One of the transistors burned, and to be sure about that, let's check some voltages while in use. Okay, this is ground. What we got here, 0.7, 0.66, 0.7, 0.66, 0.68, 6.4. Man, we are really good to go. Perfect, it's working. At the temperature in the middle there, I got 66 degrees. The other one, this little guy here, it's 52. This one here, it's like 52. Anyway, now what I'm trying to say is that better sync in a second. I'm happy. This transistor, even if it's bigger, this is better if we take it the other way. So this is kaput, the PNP. Now I have to put this in a proper way on the board. Next step is to find a proper cooling method for all of them. I couldn't find any other proper NPN transistors, so that's the single one. It has to do the job. My concern is not the form, my concern is about cooling. Let's start with these two guys. Let's clean it very well. Yeah, that should be fine. Perfect. It's perfect. Okay, that was number one. Let's do something about number two here. I have some isolation before mounting that little heatsink plastic washer there, isolating all the things. Maybe you consider I'm overdue, but I like to be secure somehow. Okay, here we are, kind of improvised heat sinks. Now I have to check for functionality. Of course, I have my phone there, hooked headphones, and power on, nice and clear. Beautiful, deep bass, sounds good. You may say that I'm overdoing heat sinks, you know. It looks a little bit overdimensioned, but you know something? This amplifier, it's working 24 hours per day. So it's a need for fiability, because this involves studio work, and you know, these guys are really playing music loud. I'm cleaning the surfaces, having some glue. This is cured almost, but this is more than enough. Something like this. Yeah, perfect. Let me have two screws for behind here, like that. Perfect. Of course, I have in my mind to make a kind of thermal junction with the top a little bit more, and we are perfect. You see, with the top case like this. That's my intention. And then the top will take also the overheat, because these are thermal pads, and a piece of something here, like this. Okay, perfect. Perfect. And now the transistors are just taking the temperature of the case. Here we have like 26-27 degrees. Okay, all the screws back in place, the volume knob, power supply, and on. No music. Okay, so the video, it's looping now. Let's check for the sound. Beautiful. Okay, I'll let it run for half an hour and then we'll check the temperatures. Here we are, people, like half hour later, and we have like 34, 37 degrees on the case. So it's looking like my project, it's working great, and I can feel the whole case somehow getting warm, but that's not a problem because that was the idea of the things. Finally, what was happening with this device? This little transistor, it's a PNP transistor, got burned because of overheat, and somehow it's amazing. You know, they did a good product. It's a professional product, let's call it. This company, Schiit, okay, they didn't put enough attention to the thermal dissipation. So finally, with a little bit of tweaking, and I may call it even modded, this device can really deliver. I hope it's useful. Don't forget to subscribe to my channel. Don't forget to push the like button too. And of course, thanks to my sponsors. Oh, by the way, this one belongs to one of my sponsors, Vlad from AMPLIFIER Records. And I may say, in fact, this is a free fixing for friends. Okay, so yeah, like always, thanks to my sponsor, thanks Vlad, thanks Radu and Chuck, and until the next one, don't forget, have fun, see you, bye bye.